Iya.
Minta. Ini beneran kayak
Iya mas. Bayar ya bentar.
Kayaknya coba mulai hari ini gue melihat
Masih bisa dibayar oleh fans hari ini. Ya belum dibayar.
Ya tapi hari ini bos. Hah? Kok kita keluar orang notis? Ya tapi belum dibayar. Tapi bakal udah terakhir. Udah oke cok. Mereka kan bayar setiap sama Jumat bos. Mereka bayar hari ini.
kapan
Kita boleh kasih. Nah itu yang kita nggak mau itu.
Pengangkatan bos sebagai ketua.
Boleh jadi.
Oke.
Felixon panggil gue guys.
Pokoknya itu bisa dibayar karena udah dibayar. Bakal dibayar hari ini teman belum. Bakal dikirim besok
Kapan malam?
Pasti lah kalau bayar hari ini
bisa.
Duit besok hari ini besok bisa. Semuanya. Enggak mejanya udah siap belum?
Udah
pasti kan? Udah
orang influencer dari dia pasti dari itu. Udah ada stoknya. Jadi kalau udah ada stoknya udah ada itu.
Aku maksud gua sampai jam 4.
Mana botol lu? Itu suka kan? Ini
Tahu
lu bisa nyentuh.
Lu bisa nyentuh businya dari
Ulangan berapa jam itu?
Karena kita emang harus bikin points.
Jadi kok masa ulangan jam 8 pagi sampai jam 4 sore? Maksudnya? Iya, dia kalau ngecek itu tinggal bikin gitu. Pulang kerja jam 8 pagi sampai 4 sore.
Wah, ada pasti juga.
Panggilan pasti. Ada panggilan. Maksudnya gimana?
Maksudnya seperti yang gue bilang.
Lu mau sore bukan?
Iya. Sholat Kamis.
Wow.
Nah, nanti ada gimana?
Jadi gimana nanti?
Jadi nanti
kira-kira
tanya apa itu?
Nanti nonton bukan besok anjing. Udah. Ya udah, gua pulang dari buat
Hari ini cuma gua di sini. Nih. Ya silakan hasil nanti. Lu butuh penambahan orang selfie. Tuh, boleh. Sangat enggak boleh. Ya, Ceki juga, Ceki. Kalau lain langsung.
Video call.
Ini kan mereka lagi soalnya.
Terus mana? Mas. Siapa namanya? Boleh bikin.
Babu.
Kamera lagi racing dari saraf.
Oh,
Termasuk boleh sama yang lu harus datang
Gua lakukan jangan besar sih.
sama ada sudah dapat PDP lu di blacklist
Biasanya orang-orang yang berpangkat sok tinggi suka
seperti MPR gitu paling berwibawa gitu
makanya gue kayak siapa yang putar-putar ini? Gak tau, kelas belum ya mungkin. I mean, today cuma ada yang baru masih.
No, I think you look and then what is doing is the framework where you just do the analysis using your legal and then you generate based on the common data you got. We'll see. This is applicable like 228, like something like 8 kita
itu yang ini yang
siapa?
Itu siapa?
Yang paling atas importer kopi ini nggak ada. Kopi ini nggak ada. Kalau lu punya sih fetish
Leader jam
Oh yeah, and then I would have to relearn kayak gini. Oh, jadi sih komunikasi sama
Terus tadi apa aja Tris? Solder, glue-gun, white paper, apa lagi?
20 juta ya. I know it's really there's a lot.
Apa yang lu pikirin muncul kata-kata ya? Gua taruh aja, gua save. Bentar mereka
Disoldering itu
soldering gun.
kalau apa reference dari SBO dua-duanya yang kan bukan tonton video kan gitu kan.
Announcement to all teman-teman yang semangat keberhasilan dan yang mempunyai power strip ya, tolong bawa power strip itu tok yang tol extension.
Itu kepake di rumah gua.
Ya udah lu telepon sini.
Lampu gua
Ya bodo amat.
RGB gua masih ada.
SG itu cuma mau kasih 5 biji aja.
Oh ya?
Iya. Mana muat, mana cukup dong. Ya gue terima aja sih. Apa yang cukup kan?
Mana aja? Pakai potong kaki.
Iya kan emang prof kan nggak kabur.
Makanya kamu gini putarin ke belakang.
Oh, the much stronger here.
Mau sekarang?
Like
Here you built it. It's literally like a custom. It's a Caliban custom made with Central. You missed that earlier.
yang perlu jago banget edit video.
Apa kita tolong idenya dia jual takjil? Kemarin apa cappuccino cinta?
Kartu cinta.
Kartu cinta anjing buat apa?
Cappuccino.
Cappuccino cinta.
Okay, let's start with a pretest. This time I remember. Okay, check your Google Classroom.
Pretest?
Yeah.
Pretest?
Just see it in the stream. Yeah. Design for assembly, pre and post test.
This is the test.
Artinya viewers, suppliers to monitor nanti maksudnya apa ya?
Viewer what?
Kalau viewers, suppliers to monitor.
Jadi lu mesen dari siapa, mesen dari siapa? Dia bilang viewer, supplier. Ya supplier yang mesen dari siapa?
Ya, tapi itu monitor.
Monitor kayak sedikit. Ya beda di monitor. Beda di
Low tolerance backup not really. But because less defect not really. Less documentation, sure.
Kenapa questionnya mulai dari 11 ya?
It's random.
Main
Whereby it's cut off.
Whereby it's the 60 to 50.
Oh, berarti 20.
Jadi ini sempat jadi lanjutannya dari kemarin. Iya. So you should be registration.
San, Kanadan gimana San? Udah gagal? Apa? Kanadan. Sama kayak
Benefits of using accounts.
Kalau saya permission
Hah?
Yang telepon itu master.
Pengecekan untuk apa?
Buat konsep orang bolos. Ya,
Apa yang bikin?
apa yang gitu?
Iya, email ke gurunya dong.
Dari kitanya.
Bikin dong. Hati-hati dong. Kok nggak ada tugas nih? Udah tinggalnya si Peter.
Nggak ada sih kalau
Ada tugas tapi dia bilang dari kerjaan itu deh. Emang itu disuruh kerjain sesuatu? Enggak. Disuruh kerjain kayak apa dashboard itu. Tapi katanya nggak kerjain itu deh.
Dashboard.
Kerjanya naik street katanya.
Oh,
Terus ngapain dia ngomong?
Kayak kita dikasih
Yes.
apa? Enggak, apa?
Peter.
Peter.
Peter. Peter.
Kita bos.
Bapaknya Peter mau
Tapi ini saya
iya sih.
Kok ada sih?
What is your problem with this assembly?
Satu. Dua.
Gila, gampang banget.
Amin.
This doesn't make it any easier to assemble. It's not like it's not that complex. It has to be.
Yeah.
When you have, so you might 3 months. I think that's 4 and post because yeah, so it has a lock limit, so it doesn't.
Ini sebelumnya aja tembus ya.
It is nice.
Itu doesn't even it's like a watch and it's screw.
Yeah. So like imagine.
It's a bit warm, isn't it?
Yeah.
Okay. Done with the break? Done with the quiz?
What are the difficulties presented here?
Emang kan itu udah bisa kalau kita panasan bisa.
Yeah.
My aim is not to.
Okay, are we good? Ready to go?
No, that's not yet. 3 more questions.
Issue?
One step up, maybe. What's contact.
Okay. Yeah, let's start. We good? Okay. So I think this is one of the topics that all engineers should know. And I figured I squeeze it here in this course because we learned about automation, and a lot of the automation stations you design, remember, are assembly stations. And robotic assembly and manual assembly, when I say manual meaning human, is a bit different. But without going into details, I think some of the fundamentals are still the same. The topic today, design for manufacturing and assembly, or in short, DFMA, becomes popular in the 90s, but I think it's still relevant up until today, because labor will always increase, labor costs will always increase, and designing something for better assembly is the theme that we're talking about today. Now we can split this into two, DFM and DFA. We're not going to talk about DFM today because it's a bit wide, and I think it's more appropriate in the course manufacturing process than automation machine design. Today we'll talk mainly about DFA. Okay? So DFM is designing something to be made easily, reliably, and cheaply. Okay? That's DFM. Because some things aren't designed right. For example, for injection molding, you want uniform wall thickness. Now, if you do have a thick area, you will see a sink mark. I don't know whether you've seen it before. Can I borrow this? Okay? Like when you see plastic housing, and then suddenly there is like an jiglok, right? A little bit indent. And that's not because of a mechanical damage. It was made with a defect. That's usually because there is a rib. So, and this is just a quick example of DFM. So let's say you have something like this. What happens is that when the mold cools down, everything shrinks, right? And in injection molding, you're talking about like 5% shrinkage, ideally 2 to 3%. And because it's still hot here, this is already cold. This is already cold, solidifies and cool, but it's still hot here. It's gonna sink, it's gonna suck in as it cools down later on. And so it's gonna pull in that surface, and what happens is you will feel that. And if there is a reflection, you'll also see the curve instead of a flat. So sometimes you see that in ribs. So let's say this is your housing, okay? And you have some ribs to strengthen it for bending, okay? And so sometimes you can see a defect here because of this rib cooling down later on. So you want uniform cooling is what you want. So that's just an example of DFM. So we'll not talk about that too much. We'll talk about DFA. Okay? So DFA consists of three main strategies when we say DFA, meaning we design something for better assembly. By better, we mean cheap, reliable, it has good, you have good confidence when you assemble something. And you do this through three things. First, you minimize the number of parts. It kind of makes sense, right? And we'll talk about some examples on that. And then you want to simplify assembly steps. You know, sometimes you gotta hold things, and then you call a friend, hey, can you hold this for me? And then you put the bolt in. That's an example where you need like 3 hands to assemble something, right? Simplify assembly steps. Standardize fasteners and subsystems. Meaning when we pick the fasteners, it doesn't matter which one I pick. Everything is just 6mm screws, right? So it's nice to have such uniformity. I know this is an old example, but vehicle assembly and cars are actually, you'll be amazed. You think like a 500 million rupiah Honda Civic is expensive, but if you know how much tooling and how many people and how long of an assembly line you need in order to assemble this car, you'll understand why it's expensive and they only make so much margin. That's why I never invest in automotive stocks, by the way, including Tesla. Well, Tesla is a tech company, it's not a car company. But you know, car companies have so little profit. Okay, airlines, automotive, avoid those. So this is an example of a before and after DFM or DFA design. This is a bumper assembly. Okay, like imagine the number of screws there, the number of parts. So in this example, you know, from 1991 to 1992, they redesigned the number of parts going down from 124 to 63 for the front bumper. And assembly time goes down from 15 minutes to 6.2 minutes. And that's a significant saving. Remember, a labor cost like in the United States will cost like $25 an hour, okay, per person. So if you have 100 people, you have $2,500 per hour. So if your machine is down, can you imagine the cost of the assembly line being stopped? That's unthinkable. Here's another example. This is a strut assembly. This is the shock absorber, right? Tie rods. And you know, instead of having 2 screws coming from the bottom, as you see here, this thing goes in and it kind of sits in that pocket, and then you put in the bolt and nut from the side. See, with this one, I mean, it's gonna have to be aligned. There are 2 nuts and 2 bolts. So here's the same thing, right? From 2 pieces it becomes 1 piece. And then there is no need for extra screws, you just put in 1. So significant savings. That's the main goal that you want, is really cost reduction. And you might think the labor cost in Indonesia is cheap. Well, first of all, it's not. In Karawang, for example, I think they're up to like 8 million gajian. And 8 million is including the cost of insurance, tax, everything else, demo buruh, and all the intangibles. And it's getting more expensive each day. Also, productivity in Indonesia is not that high. For every 2 people doing a job, you need another supervisor to supervise and make sure they do the job and do it right. So it's really, and that's why people are just afraid of making a factory in Indonesia. They'll just rather go to Vietnam or Thailand, China. Chinese is not cheap, by the way. China is not cheap at all now. But this is a side topic, but I watched a Instagram reel the other day. Tim Cook, CEO of Apple, he said, people think we go to China to make iPhones because the labor is cheap, but it's not. We don't go to China because it's cheap. We go to China because we need so much engineering. We need way too many engineers with the competence at a certain level, and you can only find that in China. Cannot do that in the US, too expensive, and not that many engineers. Believe it or not, not too many Americans want to be engineers. They will take they will be majoring in arts, literature. Don't ask me history, political science. I mean, I don't know. We Indonesians, Chinese, we're practical, right? I want to make money, so.
I think you guys, our parents would call us a failure if you go to art school.
What? Failure?
I think our parents would call us a failure if you go to art school.
Right. I mean, they will how are you going to make money? You'll end up working flipping burgers, right? So, okay, back to topic. Yeah, cost reduction. It's a multiplier effect, because once you save the cost to assemble one thing, then it kind of propagates down the line with simpler tooling and all that. So improved reliability, less opportunity for human errors, because everything is already jigged and aligned. Generally, it does increase the quality, because every time you have fasteners, you have flexibility. So less fasteners, less flexibility, the assembly is more rigid. Okay, so let's talk about some practical DFA rules. So reduced assembly cost can be achieved by following 3 steps. First, you minimize the number of parts. Second, you simplify the assembly of remaining parts. Third, you standardize existing fasteners and subsystems. We talked about that. So why would I need 2 different parts? Why should I, right? Thinking of examples here. Okay, the shampoo bottle cap, right? You have the body, you have the cap, and then you have the, what do you call that? The lid, right? Do you notice that the lid is actually molded together with the cap? Now, you can have a separate screw-on cap, but then there will be an additional cost. So, when do I need a separate part? If the parts move relative to its mating parts during the normal function, then I might need separate part, right? Because it moves, these 2 parts. Like this screen with the main body, I mean, it moves, so it has to be separate. The parts need to be of different material. Kind of obvious, right? One is glass, one is not, so it cannot be one. But don't worry, you know, sometimes you can actually co-inject, like put the glass, inject plastic around it, and then it becomes one part. So people do this, like steel inserts, threaded rods, and then you mold around that. So now the plastic, the steel rod is integrated with the plastic. So you put it in, you injection mold it. These connectors, many times they're actually molded in. So you have the wires already soldered, and then you just put it inside the injection molded machine, and you inject rubber around it. So it becomes one part, no need for assembly. So it's very creative what people can do. So, but in general, if you need to be different materials, maybe you need a separate part. But coating, plating, and other non-homogeneous methods can be used. Here, even though it moves, Small motions may be accommodated via inherent part flexibility. The example I gave you, the living hinge, that's called the living hinge, the shampoo lid, right? Or parts must be separate for serviceability requirements. That's also possible. So, if those three are not true, then make it a single unit. Okay? So if the parts are made as a single unit, is it excessive cost? Is it excessive transportation? Is there a risk of defect? If the answer is no, then make it one unit, right? So first you ask this question. If it moves, then we need separate parts. If it's different material, we need separate parts. Do they have to be separate for serviceability? No, then make it, we don't need separate parts. But if it does, then you do. So these are the determining factors whether you need separate parts or not. However, if I make it one part, is it too expensive? Is it transportable, or are you shipping like air? Sometimes you make something one unit, so it becomes so big. So when you ship it, it's too big of a volume. So these chairs are composed of several parts, right? Now, let's say I can injection mold the senderan, okay, the back part and the cushion, let's say all in one thing. Yes, I can do that. But then I have to ship the entire thing, and it becomes large. So my truck is filled mainly with air, right? And that's why for injection molded plastic chairs, they make it stackable. So when you ship it, you're not shipping air, right? You make everything one unit. It's a single big, huge injection mold for your plastic chairs, but you make it stackable. So sometimes when you make one unit, it can be excessive in transportation cost. But otherwise, make it one unit. Okay, examples. Car battery. So, I know you didn't see this, I guess, in your life. But car batteries used to have individual caps to fill in the acid. And you need to top it off from time to time. Nowadays, most of the car batteries are gel, right? Aki kering bilangnya. Tapi sebenarnya it's not kering. It's a gel inside, so you don't need to top it off. Okay, but these individual caps, then you can make it into two modules and they just snap in, for example. So reduction of parts. I'm not sure what that is, but you have this part to align to a certain location. Now you can have this tab locked into this hole, and so you become one unit. Batteries can be inserted as a module. So you put it inside the casing and then it goes in as one part instead of 6 different parts. This is called nesting, okay? So you can have a part and then you have 4 bolts, but you can also capture it into this slot and then only have a single bolt. So these are techniques to reduce the number of fasteners or to reduce the number of parts. It's called nesting. Now, you also want to be able to minimize the number of assembly surface, assembly direction, or reorientations. Okay, so if you do all these 3 things, it will lead to a simple stack-up assembly sequence. Here's some example, right? So let's say, I know this is kind of a cartoon, but this part have so many different parts to attach to it from different directions. Instead of that, make it like a platform, and then everything assembles down. And it's always nice to have gravity actually become your third hand instead of having to hold something up, right? So transistors with a heat sink, this is more parts. Now, if you come this is a threaded hole. If you come from the top only, it becomes simpler rather than coming from two sides. Here is kind of a lifting bracket or a attachment to this plate. So you have 1, 2, 3, 4, 5, 6, 7, 8 screws. And notice that it also does not have a place to rest. You're going to have to hold it at a height, at a certain height, to attach these, right? Now, here, you make this piece with some legs, and then everything just stacked up. And only 4 bolts. So the same bolts hold this piece rather than coming from the side. Sometimes certain things are made that way and you tend to just accept it as a fact and you never thought of a different way to do it. Okay. It's also helpful for a process to be in the open. Something like this is difficult, right? Because everything is inside, and so if you have big fingers, then it's hard to put things in. But instead, you just flip the casing the other way, right? So you have a base plate, components there, and then the cover comes on. Instead of this, you do that. So kind of click the stab here. Now, here, in order to get to this component, there is a restriction. So put it on the top rather than behind these transformers, for example. Okay? So everything goes to the top, and you can make everything compact and reachable, and everything is in the open. The way you measure DFA efficiency is by the time to assemble something. So therefore, having a process in the open actually improves that time. All right, alignment features. This is difficult to orient because, like, you don't have any clue which way is which. If you have this, and then maybe you have a surface that you can rest on, you know, you're not aligning 360 degrees. I don't know whether you ever replace your tire. You got a flat tire, you gotta replace it. Now, usually they have an alignment hub in the middle. So if you mount your tires or your wheels, it kind of climbs onto this round piece, and then you just need to reorient where the bolts come in, right? An even better one would be studs coming out, and then you just mount it, and then you can let go, and it's not going to go anywhere. So then you just put in the nuts. But it looks uglier from the outside. So cars these days, you know, static's most important. So instead of having studs coming out, you have bolts coming into a plain hole. So the nicer finish. In the old days, like if this is your wheel, you got these. This is what I call studs. So they got studs coming out like this. So you mount it and then you put a female nut, right? But I don't know, my car has a plain hole, and so I just put it there, and then I have to watch that these holes line up with the hub, and then I put a bolt like that. I have to put the bolt in. Okay, here is a nice guideline also. If you got something like this and you want to assemble a screw on top or here, it's unstable, right? It's unstable. So it's nice to have kind of a leg so it can stand on itself, and then you put stuff on it. Okay? So this helps in-house transport, protect sensitive parts from damage, and it really acts as a base for the module. When you look at an assembly sequence, you don't want to assemble something together and then this big part coming in. It's hard to align, but you want to have a stacked up sequence from large to small. So first the large comes in, and then smaller piece comes in later on. Okay, but if you have this large part and then this small piece wants to come in, it's difficult to handle. Okay, so you want the large part to be stable first, and then have everything else coming in later on. What do you observe?
Different size.
Like variety of sizes, variety of different types, types and size. Here, everything is the same. If you ever disassemble your laptop, super annoying if you have like 3 different lengths of screw, because see, if you use a longer screw where you're not supposed to, you're gonna damage the thread, you're gonna crack the plastic. If you have different sizes, then you gotta separate it, and you have to remember which screw going to which hole. Annoying. But if everything is the same, awesome. Just put it in a cup and everything's there. Tangling, also an issue in assembly. Say you have this is the locking washers with some sharp edges, and it can tangle itself there. But instead of having the lock washer separate, the lock washer should be integrated already with this bolt. And so you're not taking the bolt, taking the washer, putting it in, because here in the bucket of the washers, they tangle each other. And so you want the supplier, hey, give me the fasteners with the lock washers already in it, okay? Don't give me a separate part. So negotiate with your vendor. Here's a 3-wire connector. It's better if you merge everything into one and just one socket, right? Because this thing can tangle. So first of all, you have 3 assemblies, but here 1 assembly. But also, these wires will tend to tangle a lot. Sorry, my slide is not colorful, but color coding, right? I mean, you have 2 pieces. One is 1.8 millimeters. The other is 2.4 millimeters. How do you even differentiate those with a human eye, right? So you want to put colors that the red ones are 1.8 and the blue ones are 2.4. So that's something. Here is another example where you have stackable parts and they lock. How often do you try to take apart these disposable cups and it creates kind of a vacuum between them, and it's very hard to separate the cups being stacked? You try to pull it out. What can you do to prevent that? You have a longer leg, and then you have this, so this leg sits on it, so it creates an air gap, okay? And you create an air gap so when you pull it out, air can go in. So this prevents what is called a nesting lock. Remember, it might be trivial if it's just me taking off a plastic cup, but in the factory, you're working 8 hours a day, assembling like 1,000 parts per day. It's really annoying if it keeps locking to each other, right? Okay, here's what I just described. Don't do this. This one, it's a plain hole, threaded hole here, and you put in the bolt. This is hard. This is easy. You because you have the studs coming out, it holds the tire, and then you come in with a female nut. But what's the disadvantage of this? It looks uglier because on the outside you have a stud sticking out, rusted. This one, the head of the bolt can be nicer finish. I hate that, but you know. Okay. Again, there is no alignment here. When this transformer sits, there is no way to align it. Here, when you put it on, it's already aligned. Minimize assembly direction turnover. So here, you put this in this way, and then if you want an easy way to insert that, you lay it down, and then you screw this way. But this is only one direction. Okay? Only one direction. Again, you have to manipulate and coming off from different directions. Fastener reduction. Some of the examples before already showed this, right? Don't do this, do this. This one can be fixed some other way. You don't necessarily need 2 bolts. This one can be captured some other way, some holes, insert, and then only lock from one. It's not going to go anywhere unless this bolt is unassembled, disassembled. Okay? Eliminate fasteners. This one has 2 fasteners. This one, again, you go into that slot. You go into the slot, and then just one screw. This one has some obstruction putting in this bolt, right? Because of this. So you want to provide easy access to the fastener both ways. Sometimes you might have a fastener obstructed and you need to drill an extra hole just to get a tool in. That's bad. This one is too close together. What's wrong with that? What's wrong with 2 bolts being too close together?
It's not out of material in
Why do you need the space?
Oh, for tools.
Tools. Right.
Oh, yeah.
So if you don't have tools, if you didn't have enough space, the tools cannot come in. What's wrong with that? Mhm. What's going to happen to the fastener? It might break the head, or it might damage your product. So create a flat spot for the head. What's wrong with that? For? For your finger, right? I mean, if it's too deep, your finger cannot come in. You'll end up just kind of trying to drop it and hope it goes into the hole. And so by allowing this, I mean, think about it. When you design this part, you don't feel there is anything wrong, right? That's exactly the problem. Design engineers sometimes don't have assembly in mind when they design the part. They just design this and hey, on the computer it looks great, but then you throw it down to the manufacturing floor and everybody just yell at you. How can you make this kind of part, right? And so this is always the tension between design engineers and manufacturing. So you should, someday if you learn, if you work at a design engineering department, you really gotta go to the manufacturing floor and assemble it yourself, because then you'll feel the pain. Okay. When I was working, I do not work on Honda, but we have a research project with Honda, where I took my PhD. And what they do, every time you have a research collaboration with Honda or some consulting work, they send everyone, including the professors, to the manufacturing assembly line. And they put you there for 2 weeks, assembling cars. It was fun for me, but not too many people like it. I mean, think about the professors who just like to think theory and formulas. And then they got put on the assembly floor and actually tightening bolts. But why do they do that? Well, they want you to understand how to make cars. We make cars here, okay? And you need to be able to empathize with the people down there making 800 Honda Accord every day for 8 hours. If you can know the pain points there, then you can design better things. So that's the philosophy. I think it's cool. So if you go in and you get hired as any position, even accountants, they'll put you on the manufacturing floor for 2 weeks, different departments, because they want you to understand, we make cars here. Insertion cannot be done, if insertion cannot be done integral with fastening, make sure all parts are stable. In other words, you want the part to be stable, and even if without holding it, you can put the fastener in one hand, right, without holding the other part. And provide lead-in insertion. So chamfers are helpful. So when you drop it to a hole, it doesn't become stuck. Use of chamfers, pilots on circular assemblies. Alignment features, right? This VGA cables, it's hard to assemble because there is no lead-in, right? You have to have XY coordinate exactly, and then you insert it. But these things, they usually have chamfers. This one has a little bit chamfers, so it helps the lead-in, right? Also, these things are round, so they naturally fall into the hole. So these chamfers are helpful. No chamfer here. You understand chamfers, right? This little cut. What do you notice? Hmm? What exists here? Chamfers. I want you to get used to the word. Okay? Chamfers. It kind of prevents any possibility of being in this situation, because you drop it on and can get stuck. So this is called internal edges. Okay? Original design, 2 directions, single direction. So in reality, you want to eliminate any possibility that you need to adjust things. For example, like sometimes tool assembly might have some inaccuracy. So let's say a round hole and an oval hole. Why would you have this? Do you know why? Sometimes you adjust for some tolerance, right? And so you want to try to not have such adjustments, because then you'll end up with more time in the assembly process. Utilize compliance between functional surfaces. Sometimes when a plastic can be bent certain ways, so you don't have adjustments. It's always nice. So having 2 holes like this, sometimes it might not be accurate, so you have oval holes. This is fine. What I talked about here is allowing it to float, right? But this one is fixed, one is floating. They make two-piece because they want to be able to have some sliding adjustments. But if you make this thin enough, it can flex a little bit, and so it can adjust itself in ways that you need it to be.